This is tutorial 6, question 1 on drag and lift. So question 1 goes as follows. One wing of a sailplane or a glider has a rectangular shaped planar area with a length of 8 meters. One wing has an aspect ratio of 12. The wing has an angle of attack of 8 degrees with a coefficient of lift of 0.9 and a coefficient of drag of 0.009. Air density is 1.1 kilograms per cubic meter. First of all, we have to calculate the total planar area of the aircraft's wings. So we know that the aspect ratio is equal to the length of the wing divided by the width of the wing. We also know that the area is equal to length times width. So we can express that as width equals length over aspect ratio and substitute in this formula. So it's length times length over aspect ratio. So our area will be equal to 8 squared over 12, and that's times 2 because of 2 wings. Which provides us with an answer of 10,667 square meters. Alright, number 2 is the takeoff speed. In kilometers per hour, assuming that there is no wind. Alright. So our total vertical lift is equal to mg, or A rho CRM squared over 2 times CL cos BM minus CD sin BM. Right. That's taking the vertical components of the drag and lift formulas as shown in the notes. Make sure that you draw your aerofoil diagram and resolve your drag and lift forces into the various components. So substituting, we know that our mass is 350 kilograms of the plane with the pilot. So 350 is the mass times gravity. It's 9.81. It's equal to 10,667 over 2 times 1,1 CR m squared, and that's times 0.9 cos 8 degrees minus 0.009 sine of 8 degrees. So m squared then is 657.512, and CRM is 25.643 meters per second times 3.6 is 92.31 5 kilometers per hour. So that is our takeoff speed. And in this calculation, we're only looking at the vertical forces. In the next question, we're asked to calculate the total force on the towing cable at liftoff with a fuselage diameter of 900 millimeters and a coefficient of drag of 0.5. So that's 0.3. Total force on towing cable So now we're going to look at our drag formula. So our total drag in the horizontal direction, that's FD cos BM plus FL sine beta M plus our fuselage drag. Right, so that is area rho CR squared over 2 CD cos BM plus CL sin BM plus area of the fuselage rho CR squared over 2 CDF, coefficient of drag. So those are all our drag components. So if we substitute, we've got 10,667 plus 1,1 times 25,643 squared over 2 multiplied by 0,009 cos 8 degrees plus 0.9 sine 8 degrees. And then we've got to add fuselage drag pi over 4 times 0.9 squared times 25,643 squared times 0.5 times 1.1 over 2. Total drag is equal to 517,597 plus 115,039 632,636 newtons, which is equal to the total force in the cable. Right, so the glider is attached to a cable that is towed along and that launches it up into the sky, and that's the total force on the cable.